Hello and welcome to everyone. This is Neeraj Gautam. In our last class, we discussed about the analysis of centrifugal governors, which are basically self-load or gravity loaded. That means a dead weight is used to control the centrifugal force, or to balance the centrifugal force we used dead weight or self weight of sleeve. Now we will move towards the next type of governor. Those are the spring loaded governors, in which the centrifugal force is balanced by the spring forces. Now let's start today's discussion with the first governor, Hartnell governor. There are four types of spring loaded governors we will learn here, in which the Hartnell governor is the first one. So let's start the Hartnell governor. Now you can see here the image of Hartnell governor, in which two levers are pinned at O. These are our points O, okay. Black points O. And at the one end of lever, a ball is connected. This is the ball. Ball crank lever 2, ball 2, ball 1. Okay. And one end of lever is attached to the sleeve, complete sleeve with collar. Here we will place then another lever for the throttle valve. Okay, make that second arrangement. So this is the sleeve, and the levers are connected to the sleeve through roller joints or through rollers, and at the one end we added the balls. Now the fundamentals are very simple. As the sleeve is attached to the engine, as the sleeve rotates, the centrifugal force acts on the balls and ball will move in outward direction. So this lever will turn in this anti-clockwise direction. So this lobe of lever will turn in upward direction. So as the speed increases, the lever pushes the sleeve in upward direction and sleeve will lift in upward direction against the compression force of this spring. The spring is attached to the sleeve, as well as next end of a spring is connected to the frame. Okay. This is a compression type of a spring which is pre-compressed, and here the orientation shown is the orientation or configuration of Hartnell governor when the governor is at its mean position. Okay. Now there is a two possibility. That means if speed decreases from the mean level, then ball will move inward side and sleeve will down, and if the speed increases, then ball will move in outward side and sleeve will lift. For both the actions, lifting or downward motion of sleeve, there is a throttle conditions. So the governor will either open or close the throttle. So the fuel amount or the flow rate of fuel can be controlled by the governor as per the requirement of speed. Okay. Now, for example, if there is an increase in speed, definitely the load will decrease on engine. So if there is an increase in speed, then governor will decrease the quantity of fuel supplied to the engine. And if the governor speed is decreased or engine speed is decreased, then the governor will increase the supply of fuel to raise the speed again at its original mean speed level. Now, these are the terminologies used in the mathematical formulation of Hartnell governor, where m, small m, as usual, mass of ball in kg, capital M is the mass of sleeve itself. Sleeve is not considered here as a weightless. Sleeve has some dead weight, but the major controlling force is provided by the compression force of this spring. Okay. Now R1 and R2, as usual, the minimum and maximum radii of rotations in meters. Omega 1 and omega 2 are the maximum and minimum, minimum and maximum, 1 for minimum and 2 for maximum, as usual. We also considered this symbols or these abbreviations in our previous problems of dead weight type centrifugal governor, that means for watt, Porter and Proel. So R1 is the minimum radius, R2 is the maximum radius, omega 1 is the minimum angular speed in radian per second, omega 2 is maximum angular speed in radian per second, S1 is spring force exerted on the sleeve at omega 1 newtons, and S2 is the spring force exerted on the sleeve is omega 2 on the sleeve at omega 2 speed in newtons. The forces are measured in newtons, the distances are measured in SI unit, that is meter. FC1 and FC2 are the centrifugal forces acting on the balls for their minimum as well as corresponding maximum speeds. So for minimum speed, the radius of rotation is R1 and speed value is omega 1. So centrifugal force acting on the ball in outward direction perpendicular to the axis of sleeve, perpendicular to this. Axis of sleeve is vertical and the direction of centrifugal force is horizontal, is m omega 1 square R1, and FC2 is the centrifugal force on the balls, fly balls at omega 2 speed, that is m omega 2 square R2. Now S is the stiffness of a spring or force required to compress this spring by 1 mm, and X is the length of vertical or ball arm of the sleeve in meters. Okay, so this is the vertical length, that is the pivot point, this vertical, between this pivot point and the center of ball, between the pivot points and center of, and this is the horizontal distance y, this horizontal distance y between the pivot point and the point at which the next end of bell crank lever is connected to the sleeve through roller joints. Okay, so length of horizontal or sleeve arm of the lever. This vertical is called as the ball arm and this horizontal is called as sleeve arm and ball. Now R is the distance of the fulcrum from the governor axis, this which is fixed. The fulcrum is fixed here. O left side, O right side are fixed here. O left side and O right side are fixed here. I will erase this figure. This distance, from the spindle axis, this distance is R. Okay, since this governor is symmetrical about the spindle axis, therefore in both sides the distance R is same from fulcrum to the governor axis. or radius of rotation when the governor in its middle position. Okay, this is the same as the radius of rotation of balls when the governor is in its mid position or min position. Now we will see some useful relations for Hartnell governor. These are the two configurations. First configuration represent for the minimum speed and second configuration is used for the maximum speed. As we discussed that the governor axis, okay, and this is the our vertical line or vertical plane in which the ball center lies when the governor is rotating to its mid speed or mean speed. Okay, when the speed decreases, the fly balls move in inward side because a spring force will more in that case. If the speed decreases, the centrifugal force decreases as compared to the spring force as well as weight. So here there are two forces, that is the spring force S1 for minimum condition plus the weight of sleeve. When the movement created by this force is more than the movement created by the centrifugal force, the movement by FC1, and this is the movement by S1 plus weight of sleeve. When this movement is larger than this movement, then definitely sleeve will move in downward side and ball will move in inward side. So this configuration we get from the minimum speed situation. Here, let the horizontal displacement of ball from its mean position or mid position towards inward direction is A1. So A1 is the horizontal displacement of ball when the speed of engine or speed of axis of governor will decrease from its mean position to any value omega 1. Okay, omega 1 is the lowest value for lowest value. Now, in this situation, all the dimensions will change. For example, if the horizontal distance between sleeve end of the lever, the axis of sleeve is y, then it is decreased to y1. Similarly, x is reduced to any value x1. X is the original vertical distance, but when this ball arm will move inward side, definitely this vertical height is decreased by some small amount. Okay, the angle turned by the bell crank lever about the fulcrum is denoted by theta. And since bell crank lever is a single rigid object, so the rotation of this vertical arm about this fulcrum is theta. Therefore, the rotation of this horizontal arm about the fulcrum is also theta. So from the geometry, you can easily compute these two relations, this relation for H1, that means the displacement of sleeve. H1 is the displacement of sleeve when governor speed decrease from its mean position to the minimum position. Okay, so sleeve will move towards downward direction. And these are the relations. H1 is the displacement of sleeve in downward direction along the axis of governor. A1 is the displacement of mass along horizontal direction when the speed is decreased from mean value to minimum value. Okay, R is the initial radius of rotation of ball, that is the mean radius of rotation of ball, and R1 is the minimum radius of rotation of ball, which is the distance between the center of ball and axis of governor. This distance is called as R1, you can see here. Okay, now for this configuration, you can easily write the mathematical relation, this equation 1. Now similarly, if we consider the maximum speed condition, that means if the speed of governor increases, that is the speed of engine increases because of the reduction of load, then the fly ball, the centrifugal force acting on these fly ball will also increase and the lever will move in outward direction. So you can see here from the mean position, the ball will move towards the outward direction and the horizontal displacement of ball, which is perpendicular to the axis of lever, is A2. And similarly, if this horizontal vertical lobe of lever will move towards the outward direction, then this horizontal arm of lever will move in upward direction because it is pinned here, it is hinged here, it can rotate about this pinned axis. So because of that, the sleeve will move in upward direction. The vertical displacement of sleeve from its mean position is given by this H2. Now the relation between H2, that is displacement of sleeve, vertical displacement of sleeve, A2, horizontal displacement of ball, vertical arm length X, horizontal arm length Y, is given by this equation 2. By combining equation 1 and 2, we can easily find the total sleeve displacement possible, that is the sum of H1 as well as H2. This H1 and H2 are added together and we get the total sleeve displacement possible in the governor from minimum to maximum speed is H, is denoted by this relation 3. Now we know that the stiffness of a spring used for this particular displacement of sleeve is given by the change in force from minimum value to maximum force value, change in the spring force from minimum value to maximum value, and divided by the change in the length of a spring from minimum value of force to maximum value. That means force applied divided by displacement of a spring caused by that applied force. So if the V changes the force of a spring from value S1 to value S2, so net force applied on the spring is S2 minus S1 divided by the total displacement of a spring because of this force change from S1 to S2 value is given by this. So now this is the basic stiffness formula, by definition of a stiffness, and from the geometric configurations we can replace H to this relation 3, and if I substitute this value of H here, I get this a new relation of a stiffness which is between the spring force S1 and S2, R2, R1, minimum radii of rotations, maximum radii of rotations, and length of the arms of bell crank lever. The third relation of stiffness is definitely in terms of centrifugal force acting on the governors. The centrifugal force acting on the governors. Now these are the centrifugal force Fc2 and Fc1, which are equal to the m into omega 2 square into R2 Fc2, and Fc1 is given by m into omega 1 square into R. Okay, other remaining things are same. So these are the basic relations through which we can easily find the stiffness of governor. Now, these are some important points which we have to remember at the time of the calculations of the governors. First note is, unless and otherwise stated, the obliquity effect of the arms and the movement due to the weight of the balls is neglected in each practice. So, the movement created by the weight of the ball are neglected. So, in movement equation, we will consider only the weight of sleeve, the force exerted by the spring, as well as the centrifugal force. The movement developed by the arms are, movement developed by the balls are neglected. Now, when the friction is taken into account, second point, here the friction is not considered, but if the friction is considered, are taken into account, then the mass of sleeve, the weight of sleeve is considered as mg plus or minus F, where F is the frictional force. At the place of mg, we will take mg plus or minus F plus F for maximum speed by condition and minus F for minimum speed condition. Plus F for maximum speed conditions and minus F for minimum speed condition. Okay, so these are the relations, and definitely we will use these relations at the time of solving problem based on Hartnell governor by considering the friction. Okay, the stiffness are also given by these two relations, in which any random mean centrifugal force is considered here. And finally, these are the basic relation between the centrifugal forces and radii of rotations. Okay, so these are the basic fundamental of Hartnell governor. Okay, if you have any doubt or queries related to this class, you can ask us. Thank you.